Giving you guys a brief talk on writing high-performance SQL statements. I am an account manager with Percona, and I've been with the company since 2013. I have 16 years in the database industry, though primarily most of it, surprisingly, is in NoSQL databases and embedded databases. And for the past 2 years, I've been working and learning all about MySQL. So for today's talk about optimum SQL performance, I'm going to concentrate on what I feel are 3 areas of importance: optimizing your schema, optimizing your indices, and optimizing your queries. To start off with, I'd like to talk about the explain tool, which provides query optimization about your queries. This is a great tool for understanding and optimizing troublesome MySQL queries. It's been available since in 5.6 for select, deletes, inserts, updates, and replace statements. Prior to that, it was only available for select statements. It's important to understand that the explain tool only gives you an estimate on how the optimizer will execute a query. So here are all the fields that are returned when you use the explain tool on a query. However, I'm just going to concentrate on these 4 fields, which I feel are the most important. The first one is the type field, which gives you information about how the tables are joined for a query, and includes values that range from constant, which is your best value, to all, which is your worst value. The constant value is when there's only one matching index or matching record in your index table, and essentially you can then replace that column with a constant. The worst one is all, where the query optimizer has to scan the entire table to build your resultant set. The other 2 fields that are important are the possible keys, which lists the possible indices that the optimizer could use, as well as the key, which is the one that it actually does use. If you find that these values are null, then that says that no index was able to be used for your query, and that indicates that maybe you need to re-examine your query with your where clause to find out maybe you're not indexing properly your query. And finally, there is the row, which shows how many rows were examined to build your resultant set. So for examples, I'm going to use the Aquila database, and I'm just going to look at 3 tables. So the only reason I bring this up is I just wanted to show in red what the indices are. And here's the other 2 tables. So what we're building here is a many-to-many relationship between actors and the film. Okay? So I just started off with looking at an example select statement, which is just select the first name from actor, which is not indexed. And we see that the type is all, so all the rows in the actor field had to be examined. And because the keys are null, it indicates that there is no actual keys available for the optimizer to execute your query, resulting in all 200 rows had to be examined to build your resultant set. If we were to add an index to the table, we can see, and then execute the explain statement, we see that the join type is now range, so it looks for a range of values. It was able to use the index that I built previously, fn_idx, and only 13 rows had to be examined. Okay, so I was like, my select statement was, give me all first names that began with A. And there was 13 records in that particular table that satisfied that requirement. If we look at, let's say, another select statement where I had it equal to an actual constant, Alan. So give me all records where the first name of the actor is Alan. We see that the type is constant, which is your best type of join between tables. It still used the fn_idx index, and it resulted in only 1 row needing to be examined. Okay, so I would suggest that as you work with your queries, get used to the explain tool, learn it much more than I was showing here. It really can help you understand and build better queries. And my final example is where I did a nested select, and I just showed that, okay, so each column here corresponds to a table in the query statement. And what we see here is that the ID row refers to the value of the nested select. So there's two nested selects. This is your outer one. They all were able to use keys, and the number of rows that were finally examined was 8. So I'm going to look at some ideas for optimizing your schema. So what I did when I was preparing this talk, I went to our consulting engineers and I asked, what were the most common mistakes large companies make when building their queries? You know, these are queries that, or mistakes that you'd say they should know better. They're very simple, basic mistakes, and yet companies still make them repeatedly. Okay? So the first thing is you should use the smallest possible data types. Unless you're expecting to have 2 trillion users, you don't need to have a user ID be used with a big int. Figure out what is the maximum number of values for a particular data type or column, and choose your data type appropriately. Other ideas are when comparing terms, use integers, because integers are going to be, in comparing, are going to be faster than comparing characters. Use your built-ins, MySQL built-ins, such as date types and time types, and store your IP addresses as integers instead of strings. Another mistake that's commonly made is that you're not defining your columns as not null. If you have nulls in your column set, the SQL optimizer actually has a lot of problems creating an execution plan. So a simple thing is just don't use not nulls. Another thing that you can use to optimize is use the enum type instead of a string. And finally, when you're joining columns, make sure that you're joining like columns so that you don't have to convert columns when you're joining in a query. Another issue is you don't need to overly normalize your database, your schema. Some data redundancy is actually not bad. A normalized database is going to give you smaller tables. Your inserts are going to be faster. You're going to have a smaller footprint, but you're also going to have a lot more joins, which are going to add complexity and will lower your performance. A normalized database is best for write-intensive applications. A denormalized database, you don't need as much need for joins. Selects are very fast, and the optimizer is able to more efficiently optimize the indices. The downside is that you're going to have a larger footprint. You're going to have slower updates to your database, and you have a potential to put in inconsistencies in your database. And this is best for read-intensive applications. The next part I'm going to talk about is indices. So indexing is a powerful way to improve the performance of your database, and optimal indices can improve it up to 2 times. However, it may require rewriting your queries. So, to write an optimum index, so why do you index is, it reduces the amount of data that needs to be examined. You're pre-sorting your data, and you're turning random I/O into sequential I/O. When should you index? Small tables are probably not necessary to index. The overhead of indexing is probably going to be greater than the performance increase that you're going to get. For medium and large tables, indexing can be very effective. For enormous tables, the maintenance of maintaining the performance or the amount of energy to maintain your tables is going to be quite large, and it's probably not going to be effective. So to design an optimum index, There's a star or a way to rank your indexes in terms of stars that is used. An index is 1 star if it places all the relevant rows next to each other. That's kind of the definition of an index, in my opinion. It's 2 stars if the rows are sorted in the order needed by the query. And it's 3 stars if all the columns are included that are needed for the query, which is a covered index. So I chose an example to give you an idea of how this ranking works. I did a select A from table where B equals a constant order C. So a good index is going to just index the column B, okay? So all the relevant rows are next to each other. A better index is going to have a multi-column index on B and C so that the rows for C are pre-ordered for you by your query. And then the optimal index is where all the columns are needed, all the columns are indexed that are needed by the query. And again, this is a covered index. Indexing on a multi-column index, indexing on 2 columns is not the same as indexing on 2 separate columns. A common mistake is to index all your individual columns. However, with MySQL Optimizer, if you do that, the optimizer is going to merge your index anyway. And in your explain statement, you'll see that it's a merged indexed. And if that's the case, you may want to just relook at your query to make sure that it's properly indexed. And maybe a single multi-column index would be a better solution for you. When indexing multi-columns, order matters. The correct order will depend on your query, and the general rule of thumb is that you place your most selective tables on the left-hand side of your multi-column index. So for an example here, if we have a multi-column index on last name, first name, and date of birth, this is good if you're doing a full value match. Give me everything where last name is Sharp, first name is Tim, and date of birth is 11/11/63. Or you could just match on the leftmost prefix. Give me all records whose last name is Sharp, or all records who begin with S, or all records where last name is Sharp and the first name begins with T. It's not good if your query doesn't begin with the leftmost column. You can't skip columns in the index, so give me all records where the last name is Sharp and date of birth is 11/11/63, or if you can't match after the first range search. Another good index to consider are query indexes. This is where the index contains all the fields of a query. This is great because you don't need to access any additional data. It's already in the index. These entries are usually quite small and they can be cached. And the range searches do less I/O. Hash indices are great. They can be lightning fast. However, they have a lot of limitations. They don't allow for sorting, partial key matches, or equality comparisons. You can build explicit hash indices with MyISAM. However, with InnoDB, they're implicit and they're built during runtime. So if you're querying if the same value over and over again, InnoDB will recognize that and build an internal hash index. And so finally, I'm just going to look at how to optimize the queries themselves. So queries are tasks composed of subtasks. And to optimize a query, you could either make it happen faster, you could eliminate the subtask, or you could reduce the frequency of the subtask. So some basics are you perhaps retrieving more data than you need? Perhaps you're fetching more rows than is necessary, and in which case you can use limit n. So select star from table, limit n. Do you really need to retrieve all 10 million rows? Another idea is you're fetching more columns than is necessary, in which case you need to choose carefully to make sure that you're gathering the data that you actually need. So essentially, you should not use select star from. So if you use an example, again, from Sequela, I did a select star, this is bad. You should do something where, do you really need to, like in a multi-join query, such as this, you're going to return all the columns from all 3 tables. And maybe you just need to know the information about the actors, and so you would then limit it by just looking at the actors table. Another common problem that I've seen the consultants tell me is where you negate the left joins with a where clause. So what I did is I built 2 tables, table 1 and table 2, and I did a left join on this with the resultant table. And we see that it's as expected. If you have a where clause, you're going to remove the nulls, and you've kind of negated why you had a left join in the first place. It's actually quite common, our consultants tell me, that people will negate a left join by including a where clause in the query. Another issue is functions and expressions will disable indices, okay? So for example, let's say we select star from actor where the index column is part of an expression. When we look at the explain statement, we see that the possible keys are null. It wasn't able to use the index column, and it had to examine all 200 rows in the database, in the table. A better idea would be to isolate the actor ID, and therefore you can see that the possible keys and keys are actually used, and only 3 rows are examined. This is good. Or using the actor, the index column inside of a function, that will also disable the use of the indices. Another way to increase performance is with aggregate functions. These can be performance killers on data sets. And the question is, how much accuracy do you really need if you need to examine all, if you have a very large table, do you need to examine all tables? Can you do a more, get a good number from looking at a reduced number of records? So instead of looking at everything, do a subselect and average over that. If you want to do an average of 1 million records, that may not be necessary. Maybe just do 100,000 records or 1,000 records. The query cache is a great tool. It caches select statements as well as resultant sets. We generally don't recommend using the query cache. It can be, the cache will be flushed if you do any modifications on the table. However, it's really good for read-intensive applications. However, because the global mutex serializes access to the query cache, it can be a possible bottleneck. Another issue is you should know your engine. InnoDB provides you with row-level locking. It's great for write-intensive applications, and it provides recovery. If your table is primarily reads, MyISM can be a great table. And we recently added TokuDB, which offers row-level locking and compression. Some miscellaneous ideas you can do for improving performance is you can purge old data, break up your delete operations, confirm that your buffers are correctly sized. You should have your InnoDB buffer pool to be able to hold your hot data set. You should use the analyze table statement to periodically improve the statistics of your database. You can defrag your database by using the alter table, and generally you should use joins over subselects. Some Percona tools that are used by our consultants for analyzing queries is the PT Query Digest. This analyzes queries in your slow query log. The duplicate key checker looks for duplicate keys. PT index looks for unused indices in your database. Visual Explain gives you a more GUI visual use of the Explain tool. And the PT table usage also looks at how your tables are used. We've also included Percona Cloud Tools recently, which allows you to log into our servers and do performance optimization, troubleshooting, looking at queries, and you can access it through our cloud.percona.com. As you can see, I am a horrible speaker, so I apologize. I hope you learned something. If you have any questions, that's my email address. I can definitely follow up for anybody that has questions and talk to our consultants